Hey guys, sorry about the confusion yesterday with what you were working on. Today, what I'd like to do is to spend some time to go over things, just to make sure there's no confusion. So to get started, we're starting to look at the concept of atoms and elements. We already talked about a number of important elements to living things, and ideally, we should remember, hopefully, this acronym. SHNOPS, which stands for the six most common elements in living things. We see these elements stand for carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. So take a moment, let's open up our notebooks and let's write this down. This is something that we want to definitely remember. Again, these are the most common elements. So we'll pause here for a moment and I'll let you guys write that down. Continuing on, we can basically think of any element, especially these six in living things, as a building block. We can build absolutely anything that we need for life from just these six parts. So, for example, if we could draw from any elements that we wanted, we could, for example, take an oxygen and take a couple hydrogens, and what we could end up doing is we could build ourselves H2O, also known as water. And there's so many other things we can build from them as well. So some other examples. Sugar, fats, vitamins, hair, proteins, brain cells, anything that we can think of that a living thing needs, we can build from just these six elements. So here, all we're going to do is we're going to try and classify matter in a couple of different ways. So this first model, we have a number of illustrations. It's just showing the stuff that makes up all of matter, whether it's a living thing or not. So we're starting off a little bit more general. In this first square, we see a couple of circles that have been labeled as an atom. In the second example, we have some triangles, some squares, and we've got some circles. And as we move down, it gets a little bit more complicated, and you see we can come up with all sorts of different combinations. Here we have two circles and a square and one circle, two squares, again, maybe two squares here and circles by themselves, maybe a triangle, square, and a circle, and a triangle and a square. We have all sorts of different combinations. This basically represents the ways that atoms can combine together. Now the naming system might seem a little confusing, but let's talk about that. Maybe that'll help us out a little bit. This R, all they're doing is referring to, in this case, they're just using it to describe this shape. This circle is kind of round, which is where they get the letter R from. Over here we have triangles, round shapes, and squares. So just saying we have a combination of triangles all by themselves, round shapes all by themselves, and round shapes and squares that are attached together. That's why the letters are right next to each other. That represents this right here. So if we apply this idea other ways, round and a square shape, well, we've got a round shape and a square one. Square with a little 2 means we've got two squares attached together. And as we look at some of these other examples, it gets more complicated. This means one triangle, two squares, and a round. One triangle, two squares, and a round. And that's all we have here. The fact that there's no space implies that they must have no space between them. They must all be touching. And finally, in the last one, a square with 3 round shapes, a square with 3 round shapes, a triangle and a square, triangle and square. And we've got a few of those. All this is helping represent is our atoms. These are our carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, those 6 that we talked about. A chemical bond, if you notice, it's between where 2 atoms are lined up. And a molecule we see is made up of 2 different atoms. So now we want to think about maybe answering some questions about these. So now we just want to think about if we find something with a round and a square shape, you're going to circle an example of it, and then state how many atoms. Since we've got 1 round and 1 square, we could say that there's just 2. So now we want to do the same thing with the triangle squared 2r. It just means 1 triangle, 2 squares, and 1 round. So how many different atoms are found in this? We want to think how many different kinds of shapes are present. So we've got triangles, we've got squares, and we've got round shapes. We have a total of 3 shapes. In here, it says how many squares atoms are in the molecule. Well, since we've got a little 2 there, we're going to say there are 2 of them. And we're going to continue going through some of these other ones. So let's take a moment, take a look at group or question number 3 with the person sitting next to you. See if you can do the same thing with the square with 3 round shapes and the triangle and a square shape that are attached together. So we're looking for the number of different atoms, the number of different shapes in this case, and also how many different types of molecules are found in a sample of the square with 3 round and the triangle and square. Take a moment to try that out. I'll give you guys just a few minutes. Okay. Hopefully, we should see the different types of atoms are kind of like the number of different shapes. So for the square and round, even though there's 3 rounds, we technically only have 2 different shapes. With the triangle and square, again, we've got a triangle and a square. There's just 2 shapes. So here, in the next part, we're looking at another term, which is molecule. And for a molecule, you notice we're looking for the whole thing that's with all the atoms bonded together. So we've got one type of molecule, which is the square and the 3 round shapes, and the triangle and the square shape. So we have 2 possible molecules. So one more thing I'll have you guys work on, and then we're going to talk about this. We'll summarize this a little bit. Based on the illustration, when 2 atoms are touching, what is it that's holding them together? Based on the labels in the illustration on the previous page. So take a minute or 2 to think about that and write down your answer. Hopefully we should have come up with a chemical bond. Let's pause for a moment and think about what this means in a biology sense. So let's review a few terms right now. So we have the atom, a molecule, and a chemical bond. Simply put, an atom can be any single element. So for example, we could talk about hydrogen. We could talk about oxygen. We could talk about carbon. We could talk about nitrogen. A molecule is going to be a combination of several atoms. So for example, we said you could have water. You could also have something that looks like this. So we're trying to illustrate the same thing that we see on the paper, except instead of using shapes, we're using the actual elements, or at least the symbols that we use to represent them. Now, to simplify things, as most people are familiar with, when we talk about water, sometimes we'll refer to it as H2O. 2 hydrogens, 1 oxygen. So, in that case, the nitrogen and the hydrogen in the example over here, we could write as nitrogen, we only have one of them, and hydrogen, which we have 3. This, incidentally, is a chemical that is used in cleaning sometimes, which is called ammonia. So, atoms are just individual elements. Molecules are several elements bonded together that are connected. And how are they connected? Well, they're going to be connected with something called a chemical bond. And a chemical bond we often represent with a line. That is what holds the atoms together and keeps them from just falling apart. So I'm going to clear up some of this clutter, and we'll jot a few ideas down. So let's take a moment to write down a couple of these ideas. So we have an atom again, is just a single element. Molecule, it's made of many atoms and elements. And a chemical bond is just what holds those together. So example of, we could have an atom of hydrogen, an atom of carbon, nitrogen, oxygen, phosphorus, sulfur. We could also have other elements, iron, for example, at the periodic table. For molecules, that's things that are made up of more than one atom. That would include water, oxygen gas, ammonia. Other substances we'll talk about later on, for example, sugar, C6H12O6. And we indicate it with these numbers to tell us how many of each of that particular element we have in that molecule. And the last part is just the bonds that hold them together, such as with water, H2O, ammonia, which is nitrogen, and 3 hydrogens coming off of it. Okay, we use these little symbols, these little lines, sometimes just to indicate the bond that exists between, for example, the oxygen and the hydrogen atom, and the the hydrogen and the nitrogen atom. Basically, it's what keeps them from falling apart, it's what keeps us from falling apart, and it's what keeps the universe from falling apart. These bonds that exist between those atoms. When we move on to the next part, what I want us to think about is, of those substances, we want to think some things are pure, meaning that they exist all by themselves. There's only one thing you're going to find there. They're all identical. For things that are a mixture, you're going to see different particles of each. So what you're going to do is just list the pure substances here and the mixtures over here. So things that are going to be identical, things that are not going to be identical. So take just a couple moments, see if you can identify which one of those squares are going to be pure substances and which are not. Now we're going to apply that similar idea. If you have an element, again, it's just made up of one type of atom, whereas a compound is going to be made up of 2 or more different atoms. Again, in this analogy, essentially each atom is identified by a different shape. So if you have only one kind of shape, it's going to be an element. If it has two different types of atoms or more, it's going to be a compound. So we're going to go ahead and just list those names right here. And again, it should include things like, it should have our triangle, our square, and our round. Those are the letters we're using just to represent those shapes. If you think it would be easier to draw out, so rather than saying triangle, square, if you would rather draw a triangle and a square, by all means do that. So take just a couple moments to work on that. And then let's work on those questions as well. So for example, with 13, you're going to identify, based on the definitions that we've seen earlier, we're going to identify which of these is an element, what is a compound, and what is going to be a mixture. So I'll give you a few minutes to work on that. So now to put this to the test. So we see in example A, we have these two letters, a little 2 next to it. They're the same, so we have two of the same, so we can call this, we have an element. For B, we have several different types of letters. These could each be represented by a different shape, so we're going to go ahead and call this a compound. The next one, we have some sugar compounds, C6H12O6. Again, you don't have to be familiar with what that is. And H2O, perhaps you might know that's, recognize that as being water. So we have two different types of compounds mixed together, so we could call this a mixture. Here we have Cu and Zn, happens to stand for copper and zinc. Again, you don't have to know that. We should know that there are two different types of elements. We could use different shapes to represent them. So this would be another example of a mixture. CO2, it's not a mixture. We have different atoms that are next to each other, so they're bonded together. So this must be an example of a compound. And our last one, Al. That just stands for aluminum, all by itself, and we're going to say it's an element. So, perhaps fairly confusing, but here's the take-home message. We can have elements and atoms all by themselves, and we'll call those elements. If we have several that are bonded together, we're going to call that a compound. And then if we have lots of compounds together, we're going to call it a mixture. So it's sort of an increase in complexity. Elements, very simple. One thing. Here, we just have the element bromine. For compounds, many different types of atoms together. Sodium, hydrogen, carbon, oxygen. Many together, a compound. If we have many compounds together, we're going to call it a mixture. We've used a lot of different examples of all sorts of different elements that we can find on the periodic table, but again, the only ones that I'm going to ask you to be familiar with are just those 6 that make up the acronym SCHNOPS. Our carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. So I haven't gone over this whole thing, mostly because I just wanted to talk about some of the highlights. Hopefully this cleared up some of your questions. If you're still having some difficulty with this, just hold on, and again, I will be here tomorrow. So just be sure to let me know, and we'll talk about it some more. So, best of luck. Thank you guys for being patient.